Hi and Assalamualaikum. My name is Fatin Nurdiana Binti Fairos Nizam from Bachelor of Science Honors Biology at UiTM Perlis. My project is supervised by Dr. Ahmad Suhaib bin Kazali in topic of anti-skin aging effect of Centella acetica and Cosmos caudatus. And this is content that I will review. Skin is the largest organ in the body. It consists of three main layers, which are the epidermis, dermis, and hypodermis. The epidermis is the uppermost layer of the skin that contains keratinocyte and melanocyte. The dermis is the skin layer beneath the epidermis and above the subcutaneous layer, which are hypodermis. It is a thickest layer of the skin that composes fibrous and elastin tissue. Hypodermis is the deepest layer of skin that made of fat and connective tissue. Skin aging is defined as structural and functional changes of the skin. The skin aging characteristics such as the emergence of wrinkle, loss of elasticity, laxity, rough texture appearance, reduce of healing wound, age spot, and loss of skin tone. It can be classified into STC aging and STC aging. STC aging is caused by chronological and genetic factor, while STC aging is caused by environmental influence such as exposure to UV, pollution, and smoking. The main molecular mechanism of skin aging is oxidative stress that will result in distortion of transmembrane signaling pathway. Telomerase is involved in the skin aging. UV irradiation damage DNA and speed up the telomerase shortening in the sun-exposed skin, causing reactive oxygen species to form in the skin. Reactive oxygen species increase matrix metalloproteinase production that can speed up the aging process in the skin. Next is enzymes that are related in the skin aging. They have four, which are elastase, tyrosinase, collagenase, and hyaluronidase. This enzyme involved in the skin aging process. Malaysia has tropical climate due to its proximity to the equator. The unprotected UV radiation with UV index of 6 to 7 poses a significant health risk. In Malaysia, the expansion of skincare market is because of increase of female population, the spread of foreign culture, and the risk of women in the workplace. Nowadays, paraben fragrance is used in the skincare product that can harm the health in the long term. So, consumers are now switching to natural-based skincare product. The plant that I researched in the study is pegaga and ulam raja. It has antioxidant properties that act as anti-aging agent, such as flavonoid and phenolic. The scientific name of pegaga is Centella acetica, and ulam raja is known as Cosmos caudatus. The problem statement in this study is because of Malaysia have UV index 9 to 11 most of the year. Next is Malaysia have a high risk of skin aging developing. Then, most skincare and cosmetic use the harmful chemicals such as paraben, fragrance that can affect the skin. Lastly, the effect of this pegaga and ulam raja on collagenase, elastase, tyrosinase, and hyaluronidase are still unclear. The finding will help people who have skin aging problem. Next, it will find a new and safe alternative to chemical product. It also will improve the understanding of phytochemical and pharmacological properties of Malaysia plant. Lastly, it will enhance plant utilization and increase the demand because of distribution of Centella acetica and Cosmos caudatus in Asia is larger. That can give favorable impact on both the local and national economy. This is a research question of this study. The objective of the study is to extract bioactive compound from Centella acetica and Cosmos caudatus. Next is to assess antioxidant activity of the extract. Then to study the efficiency of extract in inhibition skin aging related enzyme. Due to antioxidant activity, we hypothesize that Centella acetica and Cosmos caudatus has significant anti-skin aging properties. This is method that we use in this experiment, which are plant extract preparation. Both plant use rotary evaporator and dry in incubator for 50 degrees Celsius. Next, the PPH assay. The absorber measure at 517 nanometer using thermoscientific techniques, 20 decibel spectrophotometer, and last method is tyrosinase inhibitory assay that use kojic acid as positive control and measure the absorbance at 492 nanometer. The result of DPPH shown in this figure. The color changes of DPPH from dark purple to yellow-orange indicate the antioxidant activity. Ascorbic acid acts as positive control inhibited at 92.95% of DPPH, while Centella acetica inhibited at 62% of DPPH. Cosmos caudatus inhibited at 69.72% of DPPH. The symbol of asterisk indicate the statistically significant difference compared to ascorbic acid. It concludes that both Cosmos caudatus and Centella acetica has significant antioxidant activity, but lower than positive control. This figure shows IC50 value of DPPH activity of Cosmos caudatus. Cosmos caudatus activity is 0.018 mg per ml. Inverted triangle show the mean value and the error bar show the SEM. The previous study from Indonesia show that IC50 of Cosmos caudatus is 0.023 mg per ml. This result indicate that Cosmos caudatus used in the present study exhibit a slightly higher antioxidant activity compared to the previous finding. This figure show IC50 value of DPPH of Centella acetica extract. The IC50 value of Centella acetica is 0.012 mg per ml. The diamond show the mean value and the error bar show the SEM. The present sample of the study show the better antioxidant activity compared to the previous. This figure show tyrosinase inhibition assay. Centella acetica inhibit 29.97 activity on tyrosinase, while Cosmos caudatus inhibit 40.91% activity of tyrosinase. Kojic acid inhibited 85.73% of tyrosinase activity. Cosmos caudatus has a higher inhibition of tyrosinase activity compared than Centella acetica. Centella acetica and Cosmos caudatus has significant inhibition effect against tyrosinase, which means it has potential to reduce or reverse hyperpigmentation due to the skin aging. In published result of anti-tyrosinase activity of ethanolic extract of Centella acetica and Cosmos caudatus still lag. This study report a novel bioactivity of both plant extract. As a conclusion, Centella acetica and Cosmos caudatus can cavern radical DPPH and inhibit tyrosinase even at low concentration. Cosmos caudatus shows slightly better activity compared to Centella acetica. This result provide empirical basis of the potential application of Cosmos caudatus and Centella acetica extract act as anti-aging and anti-tyrosinase agent. Based on this finding, the hypothesis is valid as both extract inhibit DPPH scavenger activity and anti-tyrosinase activity. Recommendation for future is extraction method can be changed to a more environmental friendly and advanced extraction method. Next, instead of using ethanol, use a other solvent with variable polarity index. Lastly, it is recommended that anti-collagenase, anti-elastase, and anti-tyrosinase assay are included in the future study to establish the full spectrum of anti-aging benefit of Cosmos caudatus and Centella acetica. And this is reference that used in this slide.